In this video, I will present a few problems I often see in statistical plots and give advice on how to make your plots easier to read. This list is very opinionated. You may disagree with some of the points I make, and in a few months or years I may myself disagree with what I am about to say. First, a question of vocabulary. This video is about plots, not graphs. A graph is a set of vertices with edges between them. We are not talking about graphs. We are talking about plots or charts, graphical representations of data, for instance with lines, dots or bars. The first point is not original. Label your axes. You may think their meaning is obvious, but that's only because you have spent time working with those data and with that kind of plot. The reader of your plot often has a different experience, a different point of view, and may be unsure about the meaning of your axes. I often see what I call Excel plots. Bar plots showing the evolution of several quantities over time. To read those plots, I usually take a pen and draw a line on the plot to see more clearly how those quantities change. Wouldn't it have been better if the author of the plot had drawn those lines, ideally without the distracting bars? If the individual values are important, we can highlight them with dots. Bar plots often have vertical bars with vertical text labels and numeric scales. Vertical labels are difficult to read. I have to tilt my head to read them. To limit the cervical strain, some tilt the labels instead. Why not go all the way and write the label horizontally with horizontal bars? Since I work in finance, I often deal with time series, but the way the axes are labeled tends to be confusing and difficult to read. Here is an example. First, the dates are vertical. I need to tilt my head to read them. This is uncomfortable. Why not write the labels horizontally? We now notice a much bigger problem. The date format is ambiguous. To a European, the first date looks like the 8th of January 2018. To an American, it looks like August the 1st, 2018. To a computer, it may look like the 18th of January 2008. Avoid ambiguous date formats, even if you know who your audience is. One unambiguous date format, which I do not like, consists in using 4 digits for the year and letters for the month. Whatever the order you choose, everyone immediately understands. The format I prefer is the ISO one. The year with 4 digits, a dash, the month with 2 digits, a dash, the day with 2 digits. It is more straightforward to parse and sort than the previous one. We can now see another problem. The precision of the dates is excessive. Since there's only one tick per month, and since not all are labeled, it does not really matter if they correspond to the first or the second of the month. You sometimes even see that level of precision when only every other year is labeled. Here, knowing the year is enough, but we now have the opposite problem. What does the 2019 tick correspond to? Is it the beginning of the year, the middle of the year, the end of the year? In many plots it happens to be the beginning, but not always. For annual data, for instance, the 2019 tick would correspond to the data point for that year, usually available at the end of the year or shortly after. That confusion comes from the fact that years are not points in time, but intervals. We can show those intervals on the axis. The same idea applies to shorter or longer timescales, days, weeks, months, years, decades, or centuries. When plotting a two-dimensional density, we sometimes use a gradient, but the image often looks blurry. Here, for instance, is the distribution ellipsoidal or ovoidal? We can try to tweak the contrast or use another palette. Yes, even this one. But the image remains blurry, or worse, shows clear boundaries where there are none. Yellow, cyan and purple in the rainbow palette are significantly brighter than nearby colors. The solution is simple. Instead of a continuous gradient, we can use a discrete one. The boundaries between the different colors, i.e. the level curves of the density, are less arbitrary and more numerous than those for the rainbow palette. The following plot shows the performance of a few investment strategies. How much money you would have now if you had invested $1 20 years ago. What does that plot suggest? Apparently, the blue strategy consistently outperformed the red one and still does, but is more volatile and suffered more during crises. But this plot is misleading. The blue strategy only outperformed the red one for the first 2 years, but the difference was very small after that. And it's less volatile, it suffered less during crises, not more. How can that be? Is the plot lying? To see this, it suffices to use a logarithmic scale for the vertical axis. We now realize that the blue and the red curves have very different slopes for the first 2 years, but are comparable after that. We also see that the blue curve drops less than the red one during the global financial crisis. Linear scales for wealth curves are, at best, misleading, at worst, deceiving. Some designers seem to like thin fonts, and more generally, thin lines. They may look very clean, but they are very difficult to distinguish. The thinner and shorter the lines, the more difficult it is to differentiate their colors. Increase the width of the lines. Then increase them even more, as much as possible. If the lines are short, as is the case in the legend, continue to increase their width to make the colors even easier to distinguish. If you use several colors in your plots, you need a legend. In this example, the legend is difficult to use for 2 reasons. First, the colors are in the opposite order in the legend and in the plot. It's easier for the reader if they are in the same order, or at least in the expected order. Here I was expecting the curves to go from red at the bottom to blue at the top, with the black line even above, so the legend reflects that. But if you pay attention to your eye movements when you read that plot, you will notice that you have to constantly go from the curves to the legend and back. Whenever possible, consider foregoing the legend completely and putting the labels on the curves themselves. In the art community, the Brewer color palettes are very popular, and for good reasons. In particular, they stress the distinction between different types of color palettes. Do you just want distinct colors without any order? That's a qualitative palette. Do you want a gradient showing some kind of distance to an anchor point, usually 0? You can use a sequential palette, going from white for 0 to a darker and more saturated color for the maximum. Do you want a gradient to show both positive and negative values? You can use a diverging palette, still using white for 0, but moving towards 2 different colors for positive and negative values. One type of palette may be missing though, a sequential palette but with no 0, no white on one side or in the middle of the range of values. But those palettes were designed for maps, or more generally to fill areas. If you use them for line plots, the colors are difficult to distinguish. They are too light and not saturated enough. If you cycle through the Brewer palettes, you will find a few dark ones, and after increasing the width of the lines, the plot will look fine. It looks nice, but the colors are still difficult to distinguish. For instance, here I struggle to separate the browns, and the greens as well. Increasing the line width helps, but it's not enough. The Brewer color palettes are not suitable for lines. You can design your own color palette suited to the type of plot you are making. This one is garish and perhaps too saturated, but it does the job. This one is more neutral. Ideally, you should also check that your palette is colorblind friendly. I have not done that here. There's a similar problem with scatterplots, but there might be an easier solution for them. Do not use hollow symbols. Fill them and make them as large as possible. You are then filling areas, and the Brewer palettes are designed for that. In this video, we have seen that we should label our axes, even when their meaning looks obvious, that we should replace Excel plots, bar plots to show evolution over time, with line plots, that labels should be horizontal whenever possible, in particular in bar plots, that we should avoid ambiguous date formats, that years were not points in time but intervals, that discrete gradients were easier to read than continuous ones, that honest wealth curves use logarithmic scale, that it's easier to distinguish colors on thick lines, that the colors in the legend should be even thicker, that the legend elements should be in the same order as on the plot, that the legend can be replaced by labels directly on the plot, that the Brewer color palettes were designed to fill areas and that darker and more saturated colors are preferable for lines.